Let me introduce myself first. I'm Nina Cardinal. I'm the Technical Strategy Director of Heidelberg Materials. I work in our cement business line, where we are increasingly or almost 100% involved in finding solutions, lower carbon solutions for the future of cement and concrete. Today I'm going to talk to you about zero. That doesn't mean I'm not going to talk about nothing. I'm going to introduce you to evoZero, which is our net zero cement and the first commercially available cement which will be commercially available as a net zero product. As a company, Heidelberg Materials, we have set ourselves pretty tough targets. One of the targets is that by 2030 we will have captured 10 million tons of CO2 from the production of our cements. And that will translate into an average emission of CO2 per ton of cement of 400 kilograms, which is actually a 47% reduction in CO2 associated with cement compared to 1990. And capturing CO2 is a big contribution to achieving that level. Let's look a bit first about numbers associated with CO2 emissions with cement. The main cement we have in the UK is a CEM1, and typically the numbers around CO2 are around 800, 850, 870 tons of CO2 per ton of cement. And the higher the worse, of course. How can we reduce this further with means which we are already doing now? One way of reducing it further is by using alternative fuels, which are lower in embodied CO2 than the fuels like coal we have used traditionally in the past for making fuels. And that is becoming increasingly reality. We have examples where we have run for several days with 100% alternative fuels when making our cements. We can further reduce it by decreasing here our process emission by basically using less clinker in our cement. That is using alternative cementitious materials such as ground granulated blast furnace slag or fly ash or limestone. That again is another way of reducing the CO2 associated with cement. And we can do this further if we have here very high levels of replacement like a CEM3B. We can go up to 70% replacement of clinker with alternative materials. But as you can see, we are still around 200 kilograms of CO2 per ton of cement we produce. The only way to get really down to zero is we need carbon capture. CCS stands for carbon capture and storage. And that is what I will now introduce in my next slides. How do we do this? How do we get there? For us at Heidelberg Materials, as the first in the world really, carbon capture is now becoming reality. So these are real photos. These are photos from our cement plant in Brevik in Norway, where we have installed and already starting to cold commission the first carbon capture plant associated with any cement work in the world. What you see here is the absorber tower. It's actually the same one here as this one here, and I explain this a little bit further, where the CO2 from our flue gases from the cement process will be absorbed before it's then being captured. What is involved overall in this is, I hope I can make this work now on this slide. Yes. So we continue to produce cement as we have always done, but then the absorber tower absorbs the CO2 and it's then desorbed and it's compressed and stored here on land, in Norway that is, and it's then shipped for 4 days to an island which is just off Bergen, where it is being further compressed into a storage container. Here's the CO2, and it is then being pumped through a pipeline which is about 110 kilometers long to be stored and mineralized 2.6 kilometers below sea level. That is where in the past natural gas and oil were stored. We are now putting back in the CO2 from our processes there. So the process in itself in terms of storing CO2 with the valves to control the flows and so is actually existing technology. We are now applying just the process of capturing the CO2 to our cement production. The beauty of it is that the process of making cement itself doesn't change at all. So our customers, hopefully some of you here who are listening, won't have to use a new product. They can continue to use a CEM1 they are used to. It's just that we separately, in an additional process, capture the CO2. It doesn't change the product itself, it just makes it a net zero product. How is this product going to be made available? So initially it's being made, as I said, this year, later in the second half of this year in our plant in Norway, and because we have good sea connections with Norway in the UK, we can bring that cement into the UK. So it will actually be physically available, our evoZero cement from Brevik in the UK, and that comes with an EPD, an environmental product declaration attached with it as well. The other option is through a blockchain mechanism. So it might be that some of customers say in Spain want the cement as well, and we don't really want the additional CO2 associated with the transport to Spain. In that case, we have a carbon bank which is audited by a third party as well, where the CO2 which we have stored in Brevik, if we then in Spain want to sell net zero cement, we take that CO2 out of our carbon bank and allocate it to cement which is locally produced in Spain, and it's then not available anymore for the physical product from Brevik. That is to avoid additional CO2 emissions from transport, and people can continue to use their local cements as well. So these are the sort of two mechanisms by which we make the cement available in the market. And I mentioned before that we aim for this 10 million tons by 2030 and that we're serious about it. So I've spoke about Brevik here in 2024. It's actually coming online now this year. The other big project for us ourselves here, really exciting for us in the UK, we have got 3 cement works, and we are due to invest, hopefully getting government sign-off very soon, in Padeswood in carbon capture. It's in North Wales, where the CO2 will be stored in the Irish Sea through a pipeline. That is due to come online 2028-29. And then you see here another list of some very large carbon capture projects like in North America here, and then some smaller ones. An example here in Germany, which captures 70,000 tons per year as opposed to 800,000, but that is a usage project. So in that case, we will capture very high purity CO2 using a different mechanism, which can then be used in the food industry, but we can't capture all of our CO2 there in that particular case. And here is just another, I like to mention these little projects, a very small one in Morocco, in our cement works in Safi, where algae feed on the CO2 as well, but it's small amounts. The big ones are really those I explained before for Norway, where we use an amine technology to capture the CO2. So just to finish off now, it's my last slide. Why should you, our customers, use our evoZero cement? It is to meet their climate targets as well as us meeting ours, and down in the supply chain. As I explained before, you can make the same concrete as you make now because it is actually the same material, so we don't compromise in quality there. And if you want to be a sustainability leader, we have to commit to these developments. Thank you very much for listening to me, and if you have any questions, my colleague is somewhere with a microphone, so you should all be able to hear that if somebody wants to ask questions, and we're of course afterwards available as well. And if you want more information, I just go to the next slide. You can also scan the QR code here.
I was just wondering if there was any push for any projects from yourself looking at producing a carbon negative cement concrete to go beyond that.
Okay. Yeah. Even with this method, in theory, you can make a carbon negative cement. If we use biofuels in our process, which we do, If we then capture the CO2, because biofuels in environmental product declarations, they count as zero. If we then capture the CO2 from these biofuels, we actually have created a CO2 saving, a negative CO2. At the moment, we are putting that negative CO2, we will just put it into a carbon bank and won't touch it. And that is due to how EPDs are calculated. The EPD rules have not yet developed to allow us to use those negative CO2 in our calculations. And we want to be absolute transparent, and therefore we are not going to touch them at the moment. We might touch them later. That is one way of getting to actually carbon negative cement. Another one, of course, is through using supplementary cementitious materials together with our carbon captured cement. If you have negative CO2 SCMs and combine it with a net zero cement, then you get an overall carbon negative cement as well. We don't produce ourselves at the moment carbon negative SCMs. We do produce low carbon SCMs and circular SCMs as well, but there are startup companies who have claims about having carbon negative cements available. So, and we monitor those technologies, and those which we believe may be worthwhile investing in, we would clearly do so as well in the future. It's a bit intimidating asking here. We are on the stand, lots of my colleagues are here as well, so feel free to ask us afterwards as well. Thank you very much for your attention.